Alright, so in today's tutorials, we want to look at exploratory data analysis in R. And this is going to be the first part of it. In our subsequent tutorials, we'll be looking at how to do EDA with other programming languages like using Python, Stata, and SPSS as well. So we want to start with EDA in R. So first of all, we want to clear all our working space and graphics. And we can basically use this code offline to do that. I've already done that, so I don't need to do it again. So step one is to import our data set, right? So basically I've done a video on data importation to R. If you have not watched that, you can go watch that. I've done how to import different data files into R, which will help you to catch up with everything that I'm going to do here. The data that you're going to make use of is a CSV file, so I'm using read.csv, and I'm going to use the file that choose to basically choose it from the folder where I have the data being stored. So let's quickly run this code offline. Alright, so I'm quickly going to my data where I have the data. I'm going to use the iris data. I'll leave this data file in the description of the video so that you can have access to it. So once we choose it, it should appear in the environment window, right? So there's the first part. The step two is to basically view our data set. So we can use the view function to basically display the data set in a spreadsheet form, or we can just click on this to basically view it. So once I click on this, it will just show me the iris data set in a spreadsheet form. The iris data set is basically was introduced by Ronald Fisher, right? And the data set consists of 50 samples from each of the three species of the iris plant. We have Setosa, we have Vescala, and we have I think Virginica. Yeah, these are the three species. 4 variables or features were measured from each sample. We have the sepal length, sepal width, petal length, and petal width. And based on the combination of these 4 features or variables, Fisher was able to develop a linear discriminant model to distinguish the species from each other. This is the data set that you're going to make use of. So let's go back. So once we view our data set, the next thing is to basically look at the structure of our data set, right? So the structure of the data set will basically display the variables with the corresponding attributes. So once we run this, we are going to see that. So for sepal dot length, so we have 150 observation, 5 variables, the same thing being displayed here. And sepal dot length is numeric, sepal dot width is also numeric, petal dot length is numeric, petal dot width is also numeric, right? And these are all in centimeters. Species is character, but we know that this is supposed to be a factor, right? Because these are the levels of the species. So we in our data preparation, which will be going through, so that will be basically going through very soon. We will realize that we will have to convert this into um, a factor instead of a character, right? So one way to also see the structure of the data set is just to click on this button, right? So we have the same thing displayed in the environment window, and we have, once you run this, it will display it in the console. Alright, so the next thing is to basically, maybe you want to check the first 6 observations, so use the head function, where then you write the name of your data, right? The assignment operator, you have assigned our data to IDAT. So once we run this, we're going to see the first 6 observations, right? And maybe you want to see the last 6 observations, you have to use the tail function. So tail IDAT display the last 6 observations. So we see that, right? So now that we have view our data set, what next? So the next thing is to prepare our data. Data preparation is something that's very important. This phase basically allows you to clean the data so that it is ready to be used for the model building phase. So there's something that we have to take a close look at. So in data preparation, I want to use this library. The dplayer library or package is very, very important for data manipulation. You can also make use of the tidyverse if you want to, but I want to make use of the dplayer. So let me run this. Alright, so once we run this, we are good to go. So what some of the things that entails data preparation? First, we have to check for missing values. Are there any missing values in our data set? We have to check for that. So we want to use this function to basically do that, which will count the number of missing values. The is.na is basically going to go through your data set like this. It will go through each of the variables and see which of the data points is missing. So um, once there's no missing value, it will state it to be false, right? But once it realizes that there's a missing value to state it to be true, then the sum function is going to count the number of missing values for us. So let's quickly run this and see what we are going to get. So we have 4 missing values, right? So how do we check for that? So let's see what next. The next thing is to basically want to show which of the rows has this missing values, right? So we are using the either, that's our data set, and we are using the square brackets. So this is a data frame. The first input here is basically dealing with the rows, and the second input here, after the comma, the second input here is basically going to is going to deal with the columns or the variables, right? So we are saying that the complete cases function basically will allow us to, let's say, return a logical vector indicating which cases are complete, right? This will return a logical vector indicating which of the cases are complete. Just this, right? This. So once we are using the exclamation mark is to negate the statement that we want to see which of the rows has missing values, right? So just using this means that we want cases or rows which are complete. But once we are using the negation sign, this it means that we want to find rows which are missing, which are not incomplete, right? So let's quickly do that to see which rows are incomplete. So once we run this, let's see what we're going to get. So yep, so row number 14 has missing values, right? And dealing with missing values is something that you have to basically look into before. Maybe sometimes it's good to delete the entire row. Sometimes you are supposed to input some values, maybe use the average of the values for this variable to basically replace them instead of just deleting. But looking at our case, we want to go by the deletion method. So we want to delete this entry with missing values. So right. So the next step is to basically delete the entries with missing values, and we are going to use um, sorry, we are going to use this function, the na.omit, right? And want to assign this data preparation to that prepare one, that prep one, yeah, that prep one. So this is basically going to delete the entries with missing values, right? It's going to delete this row specifically. So let's see what happens. So let's run this. So once we run, we see the data preparation one now has 149 observation of fiber apps, meaning it has deleted this row 14, right? So it has reduced, yes, it has reduced the sample size as well. And you have to know that anytime you are deleting rows containing missing value, it will lead to reduction in sample size or data loss, or let's say biased data. But sometimes it's good to do use the data imputation aspect, whereby you replace each of these missing values with the average values, right? So, but in our case, we just want to delete because we think it's not it is insignificant. All right, so want to check for our prepared data if indeed it doesn't contain any missing value. So we are using the same function that we have already used in here. So we see that our prepared data has no missing value. So we can proceed to the next stage of data preparation, which is checking for duplicate instance. So if there are any duplicate observation, we want to remove those duplicate instances. So we want to first of all check the dimension of our prepared data 1. So if you check the dimension, it's basically 149 observation of 5 variables, the same thing. 149 observation of 5 variables or columns. Sorry. Alright, so once we know the dimension, we want to check for duplicate instance. So these are prepared data, and we are still using the square bracket. So the first input here is to basically checking for the rows with duplicate instance, right, for all the columns, right? So we see that the columns, we didn't specify anything in here. So for our prepared data, right, we want to basically extract the duplicate observation. Okay, so let's quickly run this. So it seems this observation has been repeated. It means that this has been repeated, right? This has been repeated. So we have to basically deal with this. We have to remove this. We have the same input in one of the rows, and it has been repeated. So this is the second one. So we have to basically get rid of it. Right, so what's next? So we want to get rid of it by making use of this code function. So this is basically to extract that duplicate instance. So if you want to remove it, you have to use this exclamation mark, which is basically going to negate the statement. So it's going to remove that duplicate instance, and want to assign this kind of data cleaning to data preparation 2, right? So let me quickly highlight everything. So I want to remove that and run. So once we run this, we see that for data preparation 2 has been showing the environment window, and we now have 148 observations of 5 variables. So the data, the sample size keeps reducing, right, as we keep on preparing our data. So yes, this is one way to basically go by it. Alternative ways to remove duplicate instance, we can make use of the unique function, which is also another just another way to basically remove duplicate instance by making use of a unique function. So once we apply it on our prepared data 1, we want to assign it to prepared data 3, and let's see, we are going to see the same um, thing as data preparation 2. So let's run this. Once we run this, you see data preparation 3 also has 148 observations of 5 variables, right? And you can also make use of the distinct function in the dplayer package. So this symbol is basically the forward pipe operator, right? It basically passes the left hand side of the operator to the first argument on the right hand side of the operator. So basically for our prepared data 1, we want to remove the distance function is going to remove any duplicate instances, right? So this is another way to basically deal with or remove duplicate rows based on the columns, right? So let's run this. Alright, so you see data prepared 4 also has 148 observation of 5 variables. So this and that prep 3 and that prep 4 is basically just alternative ways as in relation to that prep 2, right? So the next thing is to basically convert our characters into factors. If you can recall, if you look at our I, that species was a character, but we are supposed to be a factor instead of a character. So we are supposed to convert those characters into factors. And how do we do this? So first of all, we are going to make use of the mutate function using the dplayer package or the dplayer library. We have the mutate function which will help us to convert our species into factors. The mutate function basically adds new variables and preserve existing ones. That's what the mutate function does. So we want to assign this data preparation to find out that, right? this is going to be the basically our last stage, of course, from what we are observing. So let me highlight everything. So for data prep 2, we want to basically mutate or change the species into factor, right? So species, we want to change it to a factor. So let me quickly run this. So once we run this, we see final that's now showing our environment window. So let's look at the structure of our final dat. So here we go. So we see that now if you check that of species, it has been converted into a factor with 3 levels. Setosa has been assigned the value of 1, Vesicola will be assigned 2, and Virginica will be assigned the value of 3. As I've already explained in our previous tutorial, that with categorical variable we can basically assign numbers to them, and the numbers are just for indication purposes, just to distinguish between the categories, right? Alright, so once maybe you may like to rename the factor levels, right? So how do we rename the factor level? Maybe you don't want to use Setosa, Vesicola, or Virginica, you want to rename it. So first of all, let's look at the levels of our final dat. That's the species. We use this $sign to basically extract, or basically yes, extract the variable from our final dat. If I omit this, let me omit this, and once I introduce the $sign, it will show me the variables. So we have separ.length, separ.width, peta.length, peta.width, and species. I want to make use of this, so once I choose it, I can check for the levels. So let's run this. So we have Setosa, we have Vesicola, and we have Virginica, right? Sorry for that. So these are the levels. So now I want to basically use, or this is the first method, of course. I want to basically assign a different level of altogether. I don't want to use the original names Setosa, so I want to assign Setosa. I want to assign A to Setosa, assign B to Vesicola, right, and assign, let's say, C to Virginica, right? Oh, yep, that's basically what I want to do. I want to rename this. So instead of Setosa, I'm going to use A, right? That's for Setosa. Instead of Vesica, I'm going to use B. Instead of Virginica, I'm going to use C. So let's run this. So once we run this, now let's check the levels of our final dat species. So we see that it has changed to ABC. Now if you click on final dat, you see that species has now been changed, that the levels has now been changed to A, and wherever I have my vesicle, it has now changed to B, right? So that's the power of maybe trying to rename your factor levels. Another way to do this is to use the recode function in the dplayer library. So we can use this code offline to basically do that. Right, so find out that, then we pick our species with a $sign, then we use the recode function, we input the same, we bring our data set or data frame with our specific variable, which is species. Then we are going to assign Setosa now to A, we assign Vesicola to B, then we assign Virginica to C. So we want to go back to the original name. So let's run this. Right, now let's check for the levels. So once we run this, we have Setosa, we have Vesicola, and we have Virginica, right? So once you click on this, find out that you see the same, you see the names again now, Setosa, right? And we have Vesicola and the rest. So this is how, maybe in cleaning your data, if you want to rename some of your factor level, this is the way you can go by it, right? So next is to basically attach the data set to make the variables accessible in R, right? This is very important because, for instance, if I want to type species, right? Species. If I run this, let's see what happens. Okay, so this we are good to go. Sometimes when you run some of these variables, you may not see the results, you may not get the results. So it's good to basically use the attach function so that these variables can be accessible in R. Right, so let's run this. Right, okay. So now what next? I want to look at data filtering in our data cleaning. Maybe suppose we don't want to make use of all this data set, we want to sample some, we want to make use of, let's say, vesicolor and let's say virginica. We don't want to make use of all the species. So data filtering is very important. So using the filter function in the dplayer library, we can do that. So this is going to be our sample data one. What do we want to do? We want to filter the species, want to filter setosa and virginica. These are the levels that we want to filter. So using the pipe function from our final data, we want to filter species setosa, or this means or, right? This symbol means or in R. Or want to also pick the species, the level of virginica as well. So once we run this, let's see what happens. Alright, so we have our sample that being displayed in the environment window, so we can click on that to see our data set. So we now have only setosa and that of virginica. So we see that the observations has reduced to 98 of 5 variables, right? Another way to filter our data, maybe you want to add another argument to it. Let's say um, we want to pick the for sepal length, for instance, we have some values which are less than 5, right? So we want to pick all those values that are more than 5. You see, this one is less than 5, right? So we want to add an argument to our, let's say, data filtering. So with sample data 2, we want to filter setosa and virginica, right? And at the same time, want the sepal length for the variable in this species. We want the sepal length to be more than 5, right? And want to assign everything to sample data 2. So let's quickly run this. Alright, so we see sample data 2 has now reduced, the sample size has reduced to 70 of 5 variables. So let's click on this. So here we go, you see that the sepal length is now 5 and above, right? Greater than 5. So we don't see anything below 5. Okay, the last thing is maybe we want to select some of the from our final data, we want to select some of the variables. We don't want to use all the variables. Maybe we want to pick just 2 or 3 of the variables as well. So we are going to use the select function as well in the dplayer library to help us do this. So we want to call this sample data 3, right? So find out that we are using a pipe function, filter setosa, and we're also filtering the species virginica as well. But we have to introduce the pipe function again so that we can select. Once you bring this um, function, make sure that you press enter so that it will be on the same it can basically follow in the right format so that you can use the select function to basically pick those variables that you are interested in. So here I want to just select sepal length and petal width instead of using all the variables that we just um, picked, right? So let me go back and run this. So once we run this, what do we see? So we have sample data 398 observation by number of 2 variables, right? The first one was of 5 variables. Now we have of only just two variables, so we can click on that to see how it will look like. So here we go. So it has just speculated two variables for us, right? So let me quickly close this ones. I just want to make use of the final that, right? So this is basically how we can clean our data. These are some of the things that we can do to clean our data before we process it for data modeling or for some descriptive statistics, right?